Thank you, and hi to you all. So, indeed, with everyone else, I mean you, and everyone worldwide, because in the last few years, we did a lot of stuff with Icinga for our own monitoring system and created a lot of new stuff that we published for free use, which I want to show you in this talk. But first, a small word about who we are, what we do. I'm from Telecom MMS. That's a small subsidiary. We are mostly concerned with building and operating custom applications for our customers. So no stock software. Everything is self-built using Java, PHP, or some other programming language. So we have a pretty diverse environment. We do a lot of projects, or quite some projects a year. We offer 24/7 service for our customers. So we work the night if it's necessary. And yeah, basically, we do that with all our projects. My role in it is the role of an architect, so I'm mostly in meetings and doing presentations and watching from the sidelines. That's the stuff I don't like. The stuff I like is getting my hands dirty and building stuff, creating stuff, and fixing problems. So what you will see in the next few minutes is our journey over the past 20 years, how we built our monitoring, what we learned with it, what we created there. And after that, a few details about some special solutions we created, about stuff we open sourced, and which you can use, free to use it. So let's start our journey. The journey starts in the year 2004. Which is kind of the year of my apprenticeship with Telecom MMS. So it's it was my task to build our first monitoring, and I chose Nagios and Cacti for our monitoring. I'd like to have a small show of hands. I expect Nagios is known by almost everyone. Who does know Cacti? Ooh, nice. Nice. It's a good tool. It's had its time. It's not really. Well, it's okay in the new version if you do some special stuff, especially with networking, but not with applications and stuff. It gets really, really tricky. So what we did, we basically run this monitoring system over more than 13 years, I think, steadily growing, steadily outgrowing everything we had. We added lots of custom check scripts, a lot of shell scripts, did modifications to the Nagios C code, to the Cacti PHP code, went into update hell, went into update trap, because I was young and didn't know better. But we also did some cool things back then, like a TTS, text-to-speech integration for our alerting stuff. We had lots of custom scripts monitoring APIs, applications, databases, and everything, you name it. And we also had a central team managing all our monitoring requests, which basically was me, and later some other colleagues helping with it. And in the end, we had serious scalability issues, both on the technical side and on the social or personal side too, because a lot of projects demanding a lot of attention. An interesting part on the technical side, the graph you see here is a CPU graph of our monitoring system. And we're speaking about 2009. This was a server with 40 CPU cores. So 40 cores nowadays is not much. I remind you, 2009 was the year where 4-core CPUs were kind of special and the good stuff. Just to put it in kind of a scale. So in 2017, we started a project to redesign our monitoring from the ground up with a new solution, with a new approach. And I gave a talk in OSMC, which covers all the bloody details. I'm keeping it concise here because we don't have much time. Basically, we picked out 5 promising challengers for our tool selection, which was OpenNMS, CheckMK, Prometheus, Icinga, and Zabbix. So while evaluating them, we disqualified, or we didn't choose OpenNMS and CheckMK because they are very opinionated, very template-focused, and very constrained for our use cases. they expect you to kind of establish one standard and roll it out everywhere, which is not compatible with our diverse projects and changing requirements and everything. We also vetted out Prometheus, because Prometheus then was pretty young, pretty rough, and did too little for us. So we had to do a lot of the stuff ourselves. In the end, we were between a choice with Icinga and Zabbix, and was kind of like a head-to-head run, because both tools are pretty great. Both have their unique use cases, but in the end, we decided to use Icinga. Not related to that theme, but it's kind of a nice remembrance there. And so with Icinga, we built our first new monitoring setup. And since I'm an architect, I brought a diagram with me. So that is what we built. We chose to build a central monitoring system in which we have the Icinga cores and some other stuff in these red bubbles. Those of you who can read it already saw we used Kubernetes as a platform. So all these are containers in Kubernetes, which we set up to work in a cluster environment. We cared for Icinga core to be in a redundant cluster, so we had two masters running. Everything else, like Grafana, InfluxDB, or the web server, we only had a single instance because we trusted Kubernetes to do this for us pretty well. And then we connected our external monitored systems via Icinga agent, via satellites, via NRPE, SNMP, and some other protocols. That was our first production setup, which ran since 2017 with most of our projects. We have some pretty nice achievements from this year. So we finally cleared up our central monitoring team. They are just responsible for keeping the monitoring software running and not for fulfilling every request and every configuration in monitoring now. We also offered a full self-service to all of our admins and users, which was heavily demanded because they wanted to get their monitoring fast and like they wanted. And we got some scalability into this. Because of the Kubernetes cluster, we got some pretty good resource scheduling, growing the system project by project with one Icinga instance more and more was no problem. It scaled pretty good at the start. And we had some easier time updating our stuff because we had dedicated customer instances of Icinga, so we could update for one customer and not for one whole monitoring system, which is usually blocked by some customer because, well, the time is not right or, yeah, some other stuff. And we put some ease into our monitoring, so we created lots and lots of documentation and lots more of documentation and then even more documentation. But we also created some readily usable stuff, like a template library, like check templates, dashboards for our systems. And we also built some tools to migrate the old configuration from Nagios and Cacti into Icinga and Grafana, which basically was a one-off migration, transferring all the data and all the configuration. And we discovered that Icinga Director really worked well for our users, for our admins, because it was an easy-to-use tool to add new monitorings, to extend the system, and to basically understand monitorings if you didn't do it before. But we also had some challenges. We had to do a lot of talking. And with that, I mean a lot. I already said it. And the second part is equally interesting. Everybody is screaming for self-service and wants to do it himself or herself. But when they get self-service, they usually start to admit, how do I do this? I don't know. Maybe you can do it for me. Can you help me? And this stuff starts. Even with the most adamant people demanding I can do everything myself, they will start with, well, would you come into my team, help me a bit with it? And this was also connected to the third part. In some cases, we saw a really step backwards in quality of monitoring because people did not take into account special configurations or basically forgot what they had with the old system, started new, and had to rediscover why monitoring existed in the first place and re-implement some stuff. We also had some technical problems, mainly with our Kubernetes cluster. So Kubernetes runs containers, and if you update a container, Kubernetes expects it can restart the container anytime it gets an update. And if you do custom service checks on the Icinga masters and you do updates to these checks, you need to build a new container, roll out the new container, restart your monitoring. We had projects, especially in hot phases, like deploying their monitoring server once an hour or even more often. And that just led to an unstable monitoring because the Icinga masters were just restarting, getting new checks, restarting. And also with all this restarting, we faced some issues when we had failure scenarios. When we had big outages, what does monitoring do? It does rechecks. What does the rechecks do? They put more load on the cluster, which is unexpected. More load on the cluster leads to crosstalk and, interdependencies between the instances, and basically it was a very bad failure scenario which generated false alerts, and we are pretty much allergic to false alerts because they make your teams non-responsive to alerts, and that's not a thing you want to do. And we also had to fight some old habits, namely SNMP and NRPE, which initially was one of my targets to get totally rid of, but you don't always get what you wish for. And we also had to fight some budgeting issues with no budget for changing the monitoring system or no budget for changing procedures. A lot of people saying, but with Nagios it was in this menu and I expect my overview like this. I don't want the Icinga shit with all the reduced information where I only see what needs to be done. I want to see everything. I am the admin. I want to filter my stuff myself. Yeah, that was a pretty nice discussion. We fought it many years, and up until now I think everybody is happy. We had the last migrations in 2020. So everybody's using this system now. So it took us 3 years to migrate all projects. The last ones had to be, you had to talk to them, not very nice to do the move. And yeah, but over the years, we collected some more experience with the system, and we did some redesigns, and that's basically how it looks now. Since 2022, you see in an instant that we have a lot less containers, and spoiler alert, that's not containers, that's servers. So we ditched Kubernetes because it did cause us more trouble than it gave us possibilities and options. So that was quite a contrarian move, but it helped us a lot in getting the system stable and reducing the admin overhead for the whole environment. And now we're basically running 2 VMs in a cloud per customer, and we're scaling these VMs via an automation. And it works better than Kubernetes. It's easier, understandable, and has less moving parts. Thank you. Thank you. The world needs more Kubernetes hate. Okay. Okay. Yeah. So, so you see, we also changed some other stuff around. We now have external metrics. We have integration with Telegraph pushing data to us. That started a few years back when people discovered they wanted more metrics. And basically, that's the state of the current affairs. Life without Kubernetes can be nice. It's not doom and gloom, and you need to do it. We basically build a rock-solid system that fulfills every task like it should do. We solved a lot of our pain points, namely with configuration files and new check scripts, which required cluster restarts in Kubernetes, which are now just file updates and restart of a process, which is much more lightweight. And we still have a lot of SNMP and NRPE. And I'm conceding that sometimes it's rightfully so because of external circumstances. It's okay to use this stuff. So I made my peace with it. It's okay. And we achieved something which was pretty hard. We have a user-driven community. So we have some channels in chat. We have some meetings every month or so where the users meet and exchange their experiences with the monitoring system, help each other, answer each other's problems and questions. And that was basically the most work in the whole project. All this technology worked pretty well. People don't work as well as technology. So, yeah, by the numbers, what do we have? We now have 36 instances and 90 or more projects on them. In total, like almost 7,000 hosts and more than 100,000 services in monitoring. And many happy admins, hopefully. What does the future for us hold? That's pretty interesting. Aside from Kubernetes and cloud, one thing I hear constantly and everywhere, use more metrics. Everything should be a metric. You can do everything with metrics. You don't need Icinga monitoring. You don't need anything else than metrics or traces or stuff. And somehow this hasn't come true yet. We're also talking about more integrated monitoring, like deploying agents and stuff, and also all this automatic self-healing, what, for example, Kubernetes promises, where you don't need monitoring, just make a health probe and the system will heal itself. You don't need an admin. I hope you're getting my opinion here without being too much bashing against Kubernetes. It works to an extent. It works pretty well, but there's a place where it stops working. And that's the place you need tools like Icinga and all this other stuff, like Grafana and yeah, all the other stuff. Yeah, but still we reach regularly for Icinga, especially in such cases, or when we do need some reporting for SLAs, for availabilities, when we do need external verification that something works. Basically, it's our trusted multi-tool to get stuff working and stuff reliably working without being on the edge of something failing all the time, undiscoverable. Yeah, our current focus areas in development of our monitoring. We're talking a lot with our developers about monitoring development activity, like pipelines, like branch merges and pushes in code. And we're trying to integrate our operations monitoring into this development process. Think of like your developers do nightly tests with a test description against the application. And we also want to include our system monitoring in these nightly tests because we do some very specific monitoring of our applications. We have often the case that these monitorings break when the application gets updated because the developers don't think of our use case or break something else unexpectedly, because things that are not tested will break unexpectedly. We all know that from monitoring. Another nice part we are trying at the moment is transaction-based web monitoring with Playwright, where you script like user sessions in the browser and put the results in the monitoring, and also some event-based monitoring. Yeah, on the way to our system, we also developed some very special solutions which might inspire you to copy or to adapt to your environments. As I already said, we have a lot of different check scripts, check plugins that we collect and use in our projects. And we don't want to have everyone deploying their own version of a check just to discover that this version has a bug and stuff like this. So we built a project in our GitLab instance where we basically have a manifest of checks with where does this check come from, which version should be used, and which libraries go with this check. And then we have an automated tool that builds Debian and RPM packages for all these check collections, and we can deploy these to our instances, to every OS we monitor. So we have vetted checks everywhere that are known working, that have known bugs, and we can deal with. And we're basically getting everything to behave a bit like the same. And the nice part about this is this repository with the manifest is public in our company, so everybody can do pull requests against it and update the check versions, add new checks. They get reviewed, they get tested, and once they're tested, they get committed, which is a pretty nice thing to collect everything and have everything in working order. And yeah. Another nice thing we discovered, you all know Icinga can do notifications. Did you know that Icinga can do notifications in an agent or in a satellite? Was kind of a surprise for us at some points. We use this in some systems, especially when we're talking about highly suspicious customers that are using a lot of firewalls to concern themselves or to constrain themselves. And basically what we do, we have some notification runners on our Icinga satellites and pushing notifications there. This has some problems with which node is responsible for generating the notification. It's usually on the master, and the satellite only publishes the notification. So if one of two fails, no notification will get published. So it's kind of a bit of an availability concern, but if you have no other option, this is a nice feature. What we also did with some of our customers, we changed our alarming from technical parameters to a business process view. So we stopped alarming on CPU load, full disk, and stuff like this. Instead, we started to monitor our projects with a business process modeling add-on and constructed clusters of checks that said the application is working if sub-application A, sub-application B, and cluster C are working. And we put our alarms on these business processes. That is kind of connected to the SRE approach that Google published a few years ago. What it does, it gets you talking to your customer, and you get to know what the customer needs and wants from his application. And what we discovered there, you're starting to have different talks if you talk like this with the customer. So when you're talking about the server is loaded, the web server is slow, stuff like this, a marketing-minded customer cannot do anything with this information. The people just think, some IT guy is saying something to get more budget or to tell me is important or stuff like this. Maybe they also think nice things of us, but I don't know, I can't look in their heads. But what I can say for sure is what we discovered once we started talking about business processes, like we want to monitor your email is arriving at the customer. We want to monitor that the customer can log in and select some stuff in your application. You have different talks, very different talks. And you get different visibility with the customer. And you usually get nicer talks. And the talks can get so nice that the customer wants to get notified by your monitoring system. And that's the point where you win, where everybody wins. Because that's the maximum amount of transparency, that's the maximum amount of trust you have achieved. And you also discover a lot of things about your system that you didn't know, because not everything is answered by technology questions. So you have to ask the right business questions, and for that you need the customer on board. And that was a great approach. It even helped our developers to put emphasis on the right things to develop, on the right bugs to fix, and well, on viewing their changes like the customer would view them. What we also did, we already said it, we switched in some parts to a more metric-driven approach, where we use Telegraph to insert data into InfluxDB and Grafana. And then we use Icinga only to query the Grafana alert state. And Icinga handles then the notification and display of urgent actions and dashboarding and stuff like this. It's not really great, but it works great. And that's the thing that is important. Another thing we did, which I find interesting, that was also on the Icinga blog, I think, 1 month ago, about using last check results and stuff from other checks in your monitoring configuration. So we had a problem. We want to monitor Azure APIs. Azure APIs are only accessible if you give it an authentication token. These authentication tokens are very short-lived, like I think 15 or 30 minutes, and need to be refreshed every 30 minutes or so. But when you do the refresh too often, you get locked out of Azure. So doing the refresh with every check is not possible. That works 5 times, and then you're locked out for a day. You cannot monitor anymore. So we created a check dedicated to refreshing the OAuth token, and all other checks were configured with a macro function in IDL to extract the token from the other check result. That works pretty well. I'm not sure if it's good or bad, but as said, it works. It works great. It has solved a lot of problems, and it shows what's possible. And that's a thing I find really, really cool. Yeah. Talking about cool things, has anyone of you tried to use event actions or actually used event actions? 3 hands? 4 hands? Okay, I spare the next question. Have you shot yourself in the foot with it? For those of you who don't know, event actions are things Icinga can do when a check changes a state. So it's like a check gets critical, so Icinga does a notification and starts some other script doing something in the background. When you hear it the first time, you think, oh, cool, I can restart my application and restart servers and stuff like this. That's why I painted the Rube Goldberg machine there, because that's a path that leads you to the very dark side of things, because your system will get very unpredictable, be broken in very, very curious ways, and you will get a lot of fun and nightly adventures with it. So before you use event actions, think hard, wait a few days, think harder, and then do the simplest possible thing you can imagine that is deterministic and that will for sure not break anything more. So restarts maybe not a good idea in every case. In some cases, maybe not in every case. What we use it for is usually connecting debugging information. Like if some special check gets critical, we are collecting system information, system status information, things we need to do a debugging in exactly with a snapshot from this moment, like an SOS report or something like it. Yeah, other than that, we love APIs, and that's one of the main reasons we picked Icinga 2017. Basically, every request you do against Icinga, you can add a JSON header to it, and you get a JSON response that can be used by automation and not by users. And we really liked that. And we liked it so much that we open sourced almost everything we did with it. So what did we do? We created a mobile app called Kike. It can query multiple Icinga frontends and display current views in a mobile application or in a Windows application. It's at the moment in a private repository, but it's public. It's not signed. Because of that, I cannot put it in a company repository at the moment, but we're working on that. And for everyone who's not familiar with or not at ease with web interfaces and stuff, we also have a console interface. That's called What the Call. It's intended to be used 2 o'clock at night on a console where you have just gotten 10 calls or 10 emails from monitoring, and you just want to type What the Call and get the last 10 monitoring results and a link to, or an OpenXDG link where you can open the browser directly from the console. So you don't need to click around. You can stay in your homely little console forever if you like. The next thing we did with our installation, we're doing a lot of stuff with Ansible for automating our server installs, our application configurations and stuff. And we also wanted to configure Icinga with Ansible. And with us, there was a little crowd which loudly shouted, Ansible all the way, everything in Ansible, go away with everything else. So we did it. We did a small POC. I hope most of you know Ansible. It's like an automation language where you write nice YAML files that get mangled by Python and executed against the server or an API. And at first we used the URI module, where you just add headers and URL and some parameters to send to a web server. And we kind of build stuff to see if a service template existed, to create a service template if it not existed before, and then create it with a body like this definition, or maybe to modify it if it already existed. And you can already see that's a nice POC, but it's nothing you want to have running for a long time, especially not if you got it for like 10 or 20 different objects and stuff. That's not feasible. So we created an Ansible collection to managing Icinga director, which basically turns this director configuration in this part of templated YAML, which is basically, it's a one-to-one mapping, so it's really easy to understand, I think. And this Ansible collection is part of base Ansible install since 2020. So everybody of you who installed Ansible in the last few years, you have it. You can use it anytime you want. It's right on your install. And it can manage almost everything you can do with the director web interface. There are some places where we need to, well, adapt to the newer stuff, but almost everything works. Aside from director, and we'll finish in 2 minutes. Aside from director, we also have some Ansible collections for base Icinga tasks like setting downtimes and removing downtimes, which is very handy in deployment scripts and update scripts. So we usually include it when we work on systems and stuff like it. We also have a collection of all our check plugins and also this Azure OAuth thing I described in this collection. Yeah, it's all on GitHub. I put the links here. You can use it. We did another thing. I said we use the business process in our SRE approach. And I don't know if the developer of the business process add-on is here. I don't want to insult you. It's a nice browser interface. I like it, everybody likes it. But we also like YAML. Don't ask why, we just do. So we built a plugin where we can turn your browser interface into a nice text adventure for our admins to configure and check into Git and stuff like this. Yeah. And that's basically it. I can say for sure there will be more. We still have a lot of stuff we couldn't open source yet because of internal constraints. We are committed to this approach, and we will try to publish everything we did here for you. So, with that, thank you. Are there questions?
On my way. I think that was the first hand.
I saw you using InfluxDB in the new architecture, and you've got 2 nodes. Are you using it in high availability?
Yeah.
Are you using a proprietary version?
We're not using the commercial version. I can't tell you at the moment how it's done, because I left the monitoring team a few years ago, and they implemented the HA after I was gone.
Okay. I'd be interested to find out, because it's a good system, but without HA, it's pretty difficult to put in production, and it costs a huge amount of money.
Sorry?
I said I'd be interested to know, because Influx is a good product, but without HA, it's not good in production.
I'm picking a nice answer. Influx works very well. The main problem we had with Influx is the cardinality explosion. So it was eating a lot of RAM when we put our metrics in there. And we had quite a lot crashes because of it. And we had to sometimes delete our data to get it recovered again. At the moment, we're staying with it because it works pretty solid if you hold it right. But if you not hold it right, it is a lot of pain.
I mean, it might be your scale, perhaps, is an issue, but...
Yeah, we're scaling it per customer, so it doesn't get too big.
I think we have time for one more question, and then we're going to have to move on.
Why do you want to get rid of SNMP?
Security is not my problem. No, it's a dated protocol that has many issues, especially when representing data and dealing with network problems. So one of the basic issues is its UDP. And if you got a lossy link, which you usually do if you got data center problems, all your SNMP monitoring will light up like a Christmas tree. That's one of the main points for me. The other point is clearly security. Configuring SNMP in a way that it's secure is hard once you leave the network side. So maybe that's a bit split here. If you're talking about switches, about firewalls, storages or stuff, SNMP could be okay. I still wouldn't prefer it because I like APIs. But when you start with applications and servers, I don't think SNMP is a good choice.
All right, thank you very much. Thanks for showing off those cool tools and open sourcing them. I'm sure you'll be open for questions after you're off stage as well.
Sure.
So one more round of applause, please.